Okay, so this test 12A, the first test in class 9 science chapter 12, that is sound. Okay, so these questions here, we'll find this on page 178 starting from there. So let us just take the first question, example 12.1. Go to page 178 of your textbook. Let me read the question for us. But before that, there are some formulas that we need to get accustomed to in this chapter. That is basically the speed formula in this chapter. V, denoted by V, capital, okay, is equal to lambda by T. Lambda is the numerator and T here, the time. Lambda, it means the wavelength, okay, wavelength of the sound. Lambda is wavelength, capital V is speed, and T is time. Second formula we have to be accustomed with is your, again, speed. Speed here, V again equal to, now you know here, one formula in this chapter is frequency, small v is frequency, okay, is equal to, here, reciprocal of time, so 1 by t. So if you apply the small v, 1 by t, and here 1 is there, nothing is there means 1 by t is v. So we can write here lambda into small v. Big V speed is equal to lambda into small v, which is frequency. Small v is the frequency. I repeat, big V speed, wavelength, small v frequency. Big V speed, lambda wavelength, t time. So the third formula here is this one itself. That is here frequency of sound, small v denoted by is equal to 1 by t. So these three formulas will be basically used, okay, apart from one more formula, that is distance is equal, speed is equal to distance by time. We know this one, distance divided by time. This we have learned even from the previous chapters. Okay, so let us start. So sound wave has a frequency, so we can start writing the information. As we said just now, frequency will be denoted by small v. 2 kilohertz. So we need to convert this one to SI unit. SI unit of frequency is hertz. Okay, hertz. We'll explain more as we go on. Just keep it simple. Now here, we know that 2 kilohertz. The word kilo means 1000. So 1 kilohertz, because kilo is 1000, is equal to 1000 hertz. Very common sense thing. Kilo means 1000. So 2 kilohertz, if 1 hertz you change to hertz, means you're changing here bigger to smaller. Big, unique, this one small. So we have to multiply. So as we multiply, you write your since. Okay, so as you multiply 2 into 1000, then this kilo will go over and this hertz will come in. So this will be equal to 2000 hertz is the frequency. Because everything has to be changed to the SI unit, because the textbook is following primarily the SI unit throughout the textbook. Okay, so here, this one, as we read on, wavelength is 35 centimeter. So wavelength means, as we said, lambda. So this one we write here, frequency is 35 centimeter. But we know the unit of length, wavelength, length means distance. Length is not centimeter, it is meter. We have been using this so many times, conversion of distance or length, kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. So we need to change this centimeter to the SI unit of length, meter. So small to big, so divide. So we divide this one by how many places you moved? 1, 2 to the left. So divided by 100, and centimeter will go with meter. So this one, 35 by 100 meter, which is simply, decimal is here. So because divided by 2 zeros, move to the left 2 places, 1, 2 to the left of 3. So 0.35, which means we can put here 0. This is nothing but the wavelength of the sound, that is involved in this question. Okay, so go slow so we pick up clearly. How long will it take to travel? How long means time, so t here is question mark. It take time to travel 1.5 kilometers. So the time that the sound wave will take to travel 1.5 kilometer means distance. So s usually denoted by s in our textbook. So how many kilometer? 1.5 kilometer. So we need to change this to meter, but we can do that later on also. So this is the distance. How long means the distance traveled. So distance traveled, or distance simply. So we go back to our basic formulas, the 4 formulas that we have written here, and see which one is going to apply. Now you see here, we have to find the time. So in order to find the time, let us involve the speed first. The formula for this one, number 2. So we write here, since speed is equal to lambda into frequency v. So lambda, because we have lambda and frequency here v, that's why we're involving that. 0.35 meter, 0.35 meter into frequency here is v is 2000 hertz. So 2000 hertz, right? So we have this one. As we multiply these two, use these 2 zeros here, 1, 2, then decimal move to the right and no more decimal. So 2 zeros used means only 20 left. So this is 70 and one more. So 0.35 into 2000 is 700 meter. Okay, and then we know hertz is the SI unit of frequency. Frequency is nothing but reciprocal of time. So hertz is nothing but 1 divided by second. Okay, reciprocal of time means time is in seconds, so second by 1 by second reciprocal, which can also be written as, if you bring it to the numerator, second to the power minus 1. So we can replace this one here, hertz, by second to the power minus 1. So the speed we have found out here, see, the speed. So let us write here the speed. Okay, therefore, since, let us write it here, speed. Here, the speed of sound, since the speed of sound, so speed is found out v. Once we have found out v, we are interested in the time. How long it will take to travel 0.35 meter. The time taken to travel 0.35 meter for this sound. So time, you know here, the formula for RAF, okay, this one, the speed is equal to, basic formula is here, speed is equal to distance by time. So speed into time, if you bring the numerator equal to distance, then time we want to find, so time will be equal to distance by speed. So time t, time taken, t already written here, will be equal to distance by speed. Now in this chapter we are taking distance as s, so distance by speed, and speed here just now v. We are using this formula. So this is the time taken for the sound wave to travel. Distance is here 1.5 kilometer. So just write that, divided by speed is here 700 meter per second, as we can see here. Now this kilometer is not in SI unit, so to match up with this meter we have to change to meter. So kilometer here, so 1, 2, 3 places to the right means big to small, so we have to multiply this 1.5 to, see here, kilometer, hectometer, decameter, meter. So 1, 2, 3. One place is 10, 10, 10. So 310 means 3 zeros, 1000. Then kilometer will go away. That way we change to SI unit. Here itself we can do it also. Divided by 700 meter per second. So we may as well cancel these 2 zeros. Okay, then this here meter can cancel. So we are left with our answer, final answer. As you can see there, if you use this 0 to multiply decimal, multiplying is with 0, decimal will move to the right, 1 0, so 1 place to the right, so it becomes 15. Down here is a number 7, and if you shift this second to the power minus 1 to the numerator, will become simply second to the power plus 1, which we don't write, right? Second. So it's coming out time in 15/7 seconds. So the time taken for this sound wave to travel 1.5 kilometer is this much, which we can divide 15 divided by 7. 2s are 14, and here 1 in hand. So we can write here 7. Oh, sorry. Question is here 2. So 2, remainder 1 here, and down here divisor. 2 1/7 second, like this also you can write. Or if you want to continue, then 0.0 like textbook answer, then 7 1s are 7, 3 in hand, point means 1 0 again, 4s are 28, so 2.14 second. Textbook is doing this way, so 2.14 second, 2.14 second. So next step, up to the first place only they are going. So second place is of decimal is 4, which is less than 5, means the preceding digit, the one in front, first place of decimal will not change, so 2.1 second approximately. So time taken for this particular sound wave to travel 1.5 kilometers, 2.1 seconds it takes to travel 1.5 kilometer distance. Okay, so that is your first question answer. Now let's go to the next question. That is page number same. No, they are, yeah, same page, sorry. Question number 3, the blue letters there now. We've done this now, so let us go here 3. Let's just go slow so that we get it clear. It's not hard, okay? First question done, the time taken for the sound wave to travel. What is the next question? Let us see. Okay, so here the next question. Question number 3, some page you'll find blue letters there. Page 178. Calculate the wavelength. So we can start writing the values here. We know wavelength is denoted by lambda. So this is the wavelength of the sound that we don't know, whose frequency is 220 Hertz. So frequency is given by the small v, 220 Hertz. This is okay because already an SI unit. So frequency of this sound wave is 220 Hertz. So go on, speed is also given. So here v is the speed, so 440 meter per second, 440 meter per second. This is the speed of the sound, of this particular sound. It travels 440 meter in 1 second, that means in a given medium. So we have to find the wavelength. So lambda small v, capital V, lambda small v, this is the one we have to use. So since we know by formula that speed is equal to lambda into small v frequency, and we need to find lambda, so lambda you put it capital V, and the small v you shift, means come to denominator. So that's our answer. Just a matter of putting the right values in the right places. So here 440 meter per second means if you shift this to numerator, like in most places the textbook is doing, second to the power minus 1, divided by small v here, 220 Hertz. As I said, remember, Hertz means simply 1/second or second. Any of these two you can use. So is equal to, and then here lambda. So 0 0 cancel, 22 2s are 44. So this is here 2. Everything is in meter per second by, as I say, Hertz is what? Reciprocal of time. Frequency is reciprocal of time. 1/second or second to the power minus 1. So let us replace this Hertz by second to the power minus 1. That becomes lambda, right? So these two will cancel off, and you're going to get your wavelength. The required wavelength, lambda, is equal to 2 meters. So the wavelength of this sound is 2 meters. One wavelength. Okay, so that is your answer. So here, wavelength. 2 more questions. Question 4, let us go. So question number 4, same page. Okay, let me read the question. A person is listening to a tone of 500 hertz. 500 hertz. Hertz means frequency, even if they don't tell. So as soon as we see the unit hertz, this is frequency small v. 500 hertz. Already in SI unit, this is the frequency of the sound. A tone of sound at a distance of 450 meters from the source. So distance is S, 450 meters. Already in SI unit meter is the distance of the sound of the person from the source. The distance of the person who is hearing the sound and the source, distance between the source and the person. Okay, what is the time interval? Time interval, as I said, is t. So t is equal to question mark is the time interval of the sound that we don't know, we have to calculate. What is the time interval of this? Time interval between successive compression. Interval between successive means between each wavelength compressions. Time interval between successive compressions from the source. Okay, so t we have to find. So we have to apply a formula here. We don't know t, so frequency is, I think we can apply this one directly. See here, frequency v, small v, since we know the frequency, so we just put once here frequency small v is also question mark, which is the frequency. So since we know that small v frequency is equal to 1 by t, we have to find t, right? So let us do this. V, small v, this is small letter v into t will go up, is equal to 1. So we need to find t, that's why I'm doing that. T is equal to 1 by small v. So let us calculate that. That will be equal to, time will be equal to 1 divided by small frequency is here, 500 hertz. Now as we see, this distance has been put in the question, but we don't need it. It's like a bluff. The data is not required. Okay, so here we know 1 by 500, and as we said, I want to repeat this so we get used to it, that hertz is the unit of frequency, and frequency is reciprocal of time, so 1 by second, or any one of these two we can use. So second to the power minus 1 replaces hertz. So 1 by 500, shift this one to numerator and second to the power plus 1. So 1 by 500 is, if you were to divide, it's a simple case of dividing. Inside is 1 and outside is 500. 0 point means 1 0. Still 10 is less than 500. Divisor means 1 more 0, and here's 0. I think still is going to be less. So 1 0 for this point, another 0 for this, 1 more 0, 1 more 0. 500 into 2 is exactly 1000. So the time interval between two compressions, each two compression of the sound wave is to make one compression, and for the next compression to begin, time interval is 0.002 second. That is our answer. Hope you're getting ready. So next one more question is there. It's on page number 180. I think 4 is done. So 12.2 on page number 180. Example 12.2. So let us do that, and that will conclude the test portion 12a. Okay, so this one, example 12.2, page 180. Open your textbook to page 180. I will read the question. Example 12.2. A person clapped his hands near a cliff. There's a cliff, and at a distance from the cliff, like a mountain, right? So he clapped his sound away from the cliff, okay, the sound, and heard the echo of his clapping after 5 seconds. Okay, so what is the distance of the cliff from the person? If the speed of the sound v is taken to be 346 meter per second. So here, as we read the question, s is equal to 5 seconds. That means this is the person, me, let us say that is the wall, is the cliff. Then sound went and hit the wall, reflected back and came to me, and I heard, means that my clapping sound reached the cliff, bounced back, reflect, and came to my ear. So the distance between me and the cliff, the sound has to travel twice the distance, right? So this distance is not the distance between me and this time. Okay, so this time here, sorry, this is time. So time is 5 seconds. So time taken to hear the echo, taken to hear the echo, the total time that the sound traveled from my hand to the cliff and back to my ear. So that time to reach my ear after striking the cliff is 5 seconds. It's 2.5 seconds to reach the cliff, and from the cliff to reach my ear another 2.5, so 5, something like that. Okay, so the distance, s is equal to question mark, is the distance traveled by the sound. This is not the distance between the person and the cliff. Okay, this is the distance, total distance actually traveled by the sound. That means the distance between me and the cliff, and again the cliff and me, so double the distance between me and the cliff is this. Then speed is given, speed of the sound v, 346 meter per second is the speed, sorry, speed is given, speed of this particular clapping sound, of the clapping sound, okay, the sound produced by my clapping, that kind of a sound, the speed is this much given. So this is given, we know. Since here distance is equal to, here see, speed into time, so I'll just write here, just to make it easy for you, distance is equal to speed into time. We know this general formula. So the distance traveled s, the speed here v, time here small t we're using. We can use t, okay, small t, 5 seconds, or oh sorry, small t you can use once. So the distance is this much, no? So v here 346 meter per second. This second to the power minus 1 come down means plus. The time is here 5 seconds. So we did that so we could cancel this second. So if you multiply it, 5, 6 are 30, 4 are 20, 3 in hand, so 23, 15, 17, 7, 1730 meter is the total distance traveled by the sound from me to the cliff and back from the cliff to me. So the question, go back to question. What is the distance of the cliff from the person? Okay, so let us explain this part. Already, since, okay, according to question we understand in 5 seconds, okay, sound or the echo, sound which is the echo, bouncing back of sound, echo has to travel 2 times twice the distance, twice the distance between the cliff and the person, between the cliff and the person. I think you will agree with this. You see here in 5 seconds the total time travel, clap here, sound of the clap start from here and hit the cliff and came back to my ear. So it has to travel 2 times the distance between me and the cliff in 5 seconds. So our answer would be, that is distance between the person and the cliff. So or therefore distance between the cliff, according to question, find the distance between the cliff from the person, cliff from the person will be nothing but total distance traveled by half of the total distance traveled by sound, which is from here clapping sound hit the cliff and came back, so that is double the distance between me and the cliff. So the distance between me and the cliff will be half of the total distance traveled by sound, which is s. So here half of 1730 meter. So if we cancel 2 1s are 2, 2 8s are 16, 1 in hand, 6 are 12, 1 in hand, 2 5. So the distance between the person and the cliff is 865 meter. I hope that's clear, right? So that concludes the question for this test part 12A. So you can go and give the test. Okay.